continue with that today, and tonight's homework number 2, which now you actually have on your sheet too. There you go, it's right in front of you, right? You did homework 1. Homework 1 was nice, like we said, relaxing way to get back into this, I hope. It only involved us messing with like A and B, right? Did you notice that? I don't know if you, like, just to kind of gently move us in. Homework 2, we're gonna like pull out all the stops, let you you know, regain your confidence with messing with all 4 of those letters without a calculator graphing these things. Give you the ones that are as messy as you can make them. Yeah, so hopefully this has been good. I don't plan to do anything except to like just get you back into the groove on this today, and we'll practice a bunch of problems. That's my goal for you, is to get like more fluid with this, like maybe you once were. Robin has a question.
Yeah, for the last homework that we did that was on paper, did we have to write that in our warm-up form?
Nah, you don't. It's fine. So we'll let it slide on this one. Okay. Something else I was gonna say about that. Oh yeah, and then just kind of the schedule for the week. So tomorrow we're gonna do some applications. You know, tides, Ferris wheels, right? Little predator prey model, whatever. You know, little rain, temperature, average yearly, monthly temperature, all those things that are.
Excuse me, that's
all those things that are sinusoidal in nature, maybe, that we might have in nature, a little spring spring mass system bouncing up and down, all that kind of stuff. Pendulums, all that. So we'll do some of those things tomorrow. Friday, we're on target for Friday quiz. Okay. Let's just do some more examples. Are you ready? Okay. So just to review from. Do you remember doing this? Remember that? This is for Cassie. She wasn't here on Wednesday. Okay, so here you go. Here are the notes from Wednesday. I do have like a clicker, I guess. You remember all this? Did you get it all? You good? You good? We did Desmos app. That's where we ended on, actually. That's where we ended on Wednesday. Is us messing with that Desmos app and hitting play on all of them and then watching it go. Remember that? So you can remember to do that at home if you like. So these PowerPoints are available on Google Classroom. Have you been able to find them? And you need them? Yeah, under About, go to Google Class Documents. This is where the solutions are too, right? Open in a new window. There you go. Okay. I mean, has anyone successfully added it to your drive though?
No, it just shows up and shared it with me.
That's what I'm saying. Is then you can just go to Drive from now on, right, to get the documents.
That's what I do.
Right? We've all sold our souls to Google, right? Okay. So you just open your Google Drive and there it is. So we messed around with Desmos. You can do that yourself. In fact, you know, since the PowerPoints are all up there, if you're the kind of person who likes to print them out ahead of time, you can do that too. All right. Let's. In the way of reviewing here, let's do a couple of problems, and I'm just going to let you do all the work today, and that's how it's going to be. That's how it's going to be, okay? So, notice here I'd like you to do 2 things. I'll give you 2 minutes to do these problems, and then at the end I'd like you to do 2 things. I'd like you to tell me the amplitude, period, phase shift, and sinusoidal axis for each one, but also give me a verbal description of the transformation language too, like the transformations that those represent. Okay, does that make sense? We kind of talked on the last slide there. We said we could describe in terms of both things. Kind of Unit 1 style, just talk straight up transformations. And then using these new words also. Right? So both things on each one. 2 minutes to go. And I'll call on 3 people at the end of 2 minutes. So tell me what those are. Find a nice color.
Thank you. Did you like that one? I've been a lot of times. Why do you come with your mom? Because I'm in 5th grade now. You really are.
No, it's just normally 3 years.
Oh, it's 2 minutes almost up.
No, it just starts at 3. That was not affected by like 5 things.
You're probably working on B, maybe even, I don't know, moving on to C in the next.
Oh, because it's A. You're right. Phase shift to which one?
Yeah.
You're right. Oh, that is the one. I'm so stupid.
Mother bear.
But do you know?
No, very nice.
I thought like I like I
Yeah, I used to think that was
So I got that, so I got that.
I get what you're saying. I'm not
So it's like 1.5 plus 4. But if you factor out 1.5.
Yeah, you might need to factor it out.
No, it's just more
So like,
oh, so it's 2.
There is a vertical stretch.
Well, not outside those points. I mean, still inside like the arch.
yes. No.
So
All right, you ready?
Yeah.
I believe in you, Maria. Start us off strong with A here. I want to know everything you know about A. Please, ready, go. Give me. You can start with. You want to talk transformations first, or you want to talk amplitude, sinusoidal access, phase shift, period first? And she wants to go with that. All right, amplitude is 0.5. Keep going. It is still 2 pi. We haven't messed with it at all. Yeah, let's clarify by saying right. I like that. Keep going. Disagree. Okay, and then also, you're not off the hook yet, sorry. The transformation language. Can you say it in transformation language from Unit 1? Talk to me about translations and dilations and all that kind of stuff. Right? Reflections. We'll start with a 0.5. What does that represent? It's something. Yeah, you got it eventually. All right, vertical shrink by a factor of what? By a factor of 1/2. Good. Anything else you want to say there? Yeah, right 3, up 1. Grant, thank you, Maria.
Yes.
Talk to me about B. You all right there?
Yeah.
Okay, we got you. Go, go.
Explaining.
I want you to do the same thing that Maria did so excellently.
Amplitude is -4.
Well, let's just report it as 4, but I hear you.
The period is 4 pi, and phase shift is 4 to the right, left. And then
Okay.
sinusoidal access is y equals 0.
I heard some whispers of dissension out there. Do you want to raise a ruckus about that, Olivia?
You have to factor out the 1/2. So actually,
Oh, alright, maybe. Alright.
So what, yeah, what do we have then? Alpha plus 8. Is that cool? It's certainly true. I think all of us agree that we can rewrite it that way. But that does show us then, that does reveal what the horizontal translation is, what the phase shift is. Okay, so let's make that correction. Important observation. In a minute, I'll go to ask you to graph one of these too, and I'll give it maybe 2 like that, and you'll need to maybe factor it out, you know, so make sure you're ready for that. You want to take the transformations too? Grant, go ahead.
Sure. Vertical stretch by 4, reflect across the x-axis, horizontal stretch by half, and then shift 8 by 4.
Yeah, let's say a horizontal stretch by 2, by factor of 2.
Sure.
So, all right. And then, what'd you say?
Shift 8.
And then left 8, yeah. Good, and then the last one, let's get that one, Deeksha. You can.
Amplitude is 3/2. The period is 2π/3. The phase shift is 0. And the sinusoidal axis is y equals -4. And for the transformation, the horizontal shrink by a factor of 3.
Or we could say by a third. I don't know. Whatever people mean by that, I don't know. Yeah.
And ring has vertical
Okay.
transformation.
Yeah. Good. We good on those? A question.
So when
Go
you're
ahead,
writing
Chris.
period, like if there's like a degree sign with the there's a degree sign with the variable, do you just assume that's in like pi?
Yeah, actually, and I have an example here in a minute. I'll give you one that has a degree symbol in it, and there we'll use degrees. But in general, if it's not said, we'll assume radians. Yeah.
So when it's horizontal strength by a factor of 1/3, that's the 1/3 that like vertical strength by a factor of 3.
I'll know what you mean. If you say shrink, I think we'll know what we mean, right? If you use the word shrink, I'll know that by 3 you mean divide by 3. Whereas what I'm saying, I guess I mean multiply by a third. In both cases, we mean the same thing, and we're both talking about a shrink, so we're good. Yeah, we had that conversation in Unit 1, and by the way, I think this is a wonderful place to rehash the conversations we had from Unit 1 about transformations, because this is like a great playground as we move these around. I think some people, I even heard some people talking about this a second ago as we were working on these. People were like, you know, I heard someone say this just a minute ago, I used to think a vertical stretch and a horizontal shrink were like the same thing. Well, if there's anything that will dissuade you of that, it's this kind of graph, right? It's very clear that if you stretch or shrink vertically a sinusoid, there are some key points that don't change at all, namely the zeros, right? None of those zeros move as you do a vertical stretch or shrink. Try as you might all day long, you can't change the zeros. Whereas horizontal stretches and shrinks will, and try as you might, those won't change the amplitude, right? So it's very, very clear here visually that the transformations we talked about in the first unit really become very clear and apparent here, what they're doing. But just to remind you, this whole column on the right over here that we just wrote could have been done by a Unit 1 student, like the Unit 1U, or in fact, anyone who had never even studied trig functions, right? Could have done this column over here if they knew anything about transformations just of functions in general, right? They wouldn't have. You don't have to know anything about trig to do the right column at all. And now we have these new words over here, so that's neat. New words, neat. Yeah.
Can we go over like if we're gonna graph these order of operations again, like which transformation we should do first?
I would, if you're committed to factoring this out always, and I think you are because we talked about it, you and me, just a minute ago, then I think it's safe to just say do reflections and stretches and shrinks first, and then do your shifts left and right. Though, if you want to be tricky, you are correct in saying that this is a shift to the left by 4, followed by a horizontal stretch by 2. And technically that is correct if you do it in that order. But you hear me? I'm just saying, you know, that from taking geometry, that that our transformations are not commutative, right? A rotation followed by a reflection or something is not necessarily the same as the rotation, reflection and then the rotation or whatever, right? And the same thing is true here. But if you just want to like have a real safe answer, factor this out. Just be careful to always do that, and then just always apply dilations and reflections first, followed by translations, and then you'll always be safe. All right, like I told you, as advertised, we're just going to practice a couple of these today. We'll run through them, okay? Let's make sure we're getting good. This first one should be the first two or so or three I think I have are similar to ones you did in the homework, and then eventually as we go we'll get to harder ones that involve like an H and a K too. We all throw these things in the mix, but in all things these should be somewhat reviewed too. So don't be scared. Yeah, good question before. Over how many periods should we do? Do at least one if I haven't told you. A lot of times we'll actually tell you though. Please grab 2 periods or something. So do whatever you like on this one though, because I didn't tell you. Do at least 1 period though. Yeah, show me at least 5 points clearly on the graph. So either label them or make it clear from your scale. And by those 5 points, I think you know which 5 points I mean. That is, I want to make sure it's obvious from your picture where the maximum bins are, where the delivery points are. Yeah, there's also points for aesthetic qualities here. You beautifully make the curves. Some of you are better at this than others, but that's good. That's one more reason why we practice. That needs a little bit of work, but even if you're technical knowledge is out there.
It was correct.
I was trying to get it out of the way so no one would trip.
I would, as long as you're careful to do that back right now. There is a charging area back there. Watch out, actually, really good. It's supposed to graphing exercise.
Never mind, I'll just do my shots.
No one just take shots. Just stay alive.
It's fun yet? Pretty much. Go ahead.
I swear.
Wait.
You know what, Robin? For you.
I'm sorry, I go through 5 years. I'm like, no. I was trying to get 5 years.
5 years. So.
Look at the equation again.
I trust you.
Exactly.
Check yourself.
No, you might have done it right.
Yeah.
somebody draw a line for me? I'm really bad. Those aren't points. These are dashes.
Exactly, that's what I just said. I just made it
I need to cast a help for lines because I'm just really bad at lines.
She is good at it.
Oh! Wait!
Cassie, have you done this before?
Wow.
I'm an artist.
So you did hire it. You outsourced that to the right person. Now keep in mind though, there's no outsourcing on a test. You gotta get good at it. Alright.
But there's outsourcing in America.
Yep. You got it. Alright, any questions or comments for Katie? Let's do another one.
Wait, it's another cosine. Wait. This is literally just going to be It's not Sorry.
It's okay.
My dad was too drunk on Thursday after this party, so we were like, there was
What's T? What's T?
No, I feel like Black Friday is
What's I?
but I Wait, no.
The period 4.
No. Pi over 2 times 2. How stupid can I be? Let's see this.
Individual to graph.
No, you're right. Never mind. I gotta go. No, it's just 4. She's right. She got it.
Actually, this looks terrible, but it's actually really good.
Did I do right?
It'll be okay.
I'm not gonna say yes or no.
At least you got it before you got it. So, yeah, it's like this, right?
Grant, yeah.
Oh, shit.
I got this.
Yeah, because I'm boring and repetitive. All I want for Christmas is money, just money. I'm not done. Yo, I already got some early Christmas money. say about the song I walked. There's gotta be a song about where I walked.
I haven't seen that one yet.
All right, give it up for Alan, guys. All right, any questions, comments about this one? I know. You just hungry for another one. Are you getting? And by the way, you saw that. This seemed like it would be a little messy at first, didn't it?
No. I mean, yes.
When you first saw it, but then you realized actually, couldn't be better. Couldn't be more beautiful, really. By the way. It's good to do this. I think all of us are doing this kind of by feel, right? Transformations, just like move stuff around, make it feel right. But remember, you can also treat this as like you would in any other normal graph. Like when you're done, just do a little reality check. For example, if you plug in 4, do you get 300? Just try, right? 4 times pi is 4 pi divided by 2 is 2 pi. Cosine of 2 pi is 1 times 300 is 300. So just to do a little reality check, right? They actually plug in some points to make sure you're actually right too. Yeah.
So let's say that you had this problem, right? But at the very end, it said +4. Would you do like everything that you just did?
Everything you just did.
And then at the very end, add 4?
You do whatever you want to do, Robin.
Wait, but I want to do it is right.
I'll tell you how I would recommend doing it.
I gave up with that a long time ago.
Here's what I would recommend doing. All right. By the way, this is a slide I stole directly from Miss Getz's PowerPoint. Okay, including this picture, everything. Okay, so I stole this from her. It sounds familiar. If you had Miss Getz, then this might sound familiar. But I thought I like it, so we'll go with it. Okay. So I just did now. All right.
Oh, come on, people. We don't need that.
Middle of the road is, of course, the sinusoidal access is what we're talking about. I might even, as we do, we haven't done any H or K things. We haven't done any H or K stuff yet, so you might be thinking, this seems overkill, I'm doing fine without all these tips. But I think you're going to want these as we move into examples where we have an A, B, H, and K all happening at once. Okay, so just keep yourself organized. I might even graph that. Keep in mind it's not an asymptote or anything, we're just using it as kind of a reference line. So just graph that real gently, dashed or light or something. How wide is the road? These first two parts are real easy, but we want to kind of create some guidelines. So if we're thinking about this as a road, then that was the midline of the road going down the center, like those lines. And how wide is the road? Well, we can use just the amplitude to go up and down from the center line. And I might graph lightly 2 other lines there, too, horizontal lines. So now we have 3 horizontal lines that kind of guide our graph. As we graph it, we're going to stay between those top and bottom line, and it's always going to be centered around that middle sinusoidal axis. So that part's, I think, pretty easy. There are no snags at all. That's very wonderful. Great. Now it gets into a little bit of a mess as we start to actually like put down some points. Where is the beginning of the road going to be? And now I hesitate to say beginning of the road because the domain here, the domain of these is all reals, right? So, but we'll just think about the beginning as being, being what? Well, not the. I'm thinking of where do we kind of think about starting? We normally think about starting at 0, x equals 0. Then we might want to think about the phase shift here.
Wow.
So I might start by kind of obeying the phase shift and try to find that place and start my, quote unquote, start my road there. Again, it's an infinite road, infinitely long. But if we're trying to nail down one period, then I might think of the start of that as being at whatever the h value is. How do I find where the end of the road, and by end of the road here, just to be clear, I mean one period later. What do we mean here? So how do I find the end of the road? What's the period? 2 pi over b, and we need to add that to our h. So that'll give us where our beginning of the road will be at like x equals h, And the end of our road will be at x equals h plus 2 pi over b, whatever that is. So that kind of gives us real clear boundaries. Now we have boundaries above and below. We have midline. We know where we're starting and stopping. And then, how do we find where, again, we're looking for 5 really clearly labeled points. In the end, I'd like to know where the maxes and mins are and where the equilibrium points are. So you've kind of already been doing this today. You might want to thanks for listening. You might want to divide your period by 4, right, in order to figure out where those marks should be. Some of you are liking the last 2 examples. Like, why was the last example so nice? The period was what on the last one? 4? And that happened to be a really nice number, right? Like, it would have been obnoxious if it happened to be 5, even though the algebra would have been good. When you went to graph it, it wouldn't have been quite as nice. You could do it. It would be fine. But why was 4 so nice? We can actually put some mathematical precision on what we mean by nice now. A nice scale is one like this, right? That it's very visibly apparent where each of those 4 pieces of the period fall, right? Where are the equilibrium points? Hopefully we've chosen a scale that makes that clear, right? Where are the maxes and mins? Hopefully you've chosen a scale that makes that clear. And doing this analysis ahead of time hopefully helps you set your scale on your graph. I think really setting up your scale on the graph and doing all the prep work is where a lot of the hard work lies, and then you're pretty much good to go. And of course, once you nail down those 5 points, then you're kind of set, aren't you? So let's do this. I think someone even suggested a second ago, whenever that was, by the degree symbol here. I mean, let's do everything in degrees this time, mainly just for fun. Okay. Okay. So let's just practice doing one of these in degrees. If you like to follow the roadmap idea, you might want to kind of mark down where those 3 lines are going to be, just lightly. Do whatever you need to do to make a correct graph of this. Ready to go? And again, without a calculator. And we'll have someone come up and do this one in a minute.
Oh yeah. Oh, I don't like this.
Actually, what do you do?
Oh, like what is it? Yeah.
Do that really slow.
Last one.
Why didn't she tell me?
Wait, so the period takes like 300 times
360. Is it 360 over 1/3, which is 360 times 3, which is 720?
720 is more than 720.
360 times 3 goes.
It's not 720. It's like 180.
Oh, combo.
1080?
Oh, you're right. Yeah.
Am I right?
Here it is 1080. Oh, yeah.
Yeah, period.
Hey guys.
Oh, wait, it goes to the bottom, right?
Still not instead of 320.
Do you just not look at like
I just couldn't get a bad
What is this?
or done with round 2.
ugly?
So ugly.
Wait a minute.
Yeah.
Probably.
Oh yeah.
Uh-oh.
You are right.
I did that one.
I don't know why.
I remember Ethan was really good at
I believe in you.
Thank you.
Oh, damn.
Boy.
Olivia, here all week. Relief.
I'll be here all week.
I'll be here all week.
Okay, do it again. $30.
$30.
30.
It's okay.
I'm gonna
Raise the bet. I need to make more money than that.
We're in the circus.
It's okay.
You can do it.
This is gonna work.
Oh, that was so close. You get points.
Not even close.
50%.
I gotta clear my mind a little bit.
Drain the swamp.
Not even. He's slipping.
I haven't gotten it yet though. Is this gonna?
He's slipping.
I believe.
Is it gonna go viral?
He's slipping. He's slipping.
Piper, not done yet.
Okay. Okay.
He had it on the hook.
How'd she do?
Impressive. That's just like the points are where they should be.
Oops. Needs a little work. But you know, the spirit.
Spirit.
Spirit. All right. Have fun. Homework 2 tonight.